Well, welcome back, everyone. What I'd like to do now is to talk about the interpretation of results from cohort studies. And it's the same issue when we talked about interpreting results from experimental studies or from cross-sectional studies. Whenever we epidemiologists see an association between a risk factor, an exposure, and an outcome, we have to eliminate alternative explanations for that association before we can conclude that the association is really reflecting the true impact, the true effect of a risk factor on an outcome. Now that happens in cohort studies also. So the first thing I'd like to talk about is the role of bias. Now remember what bias pertains to. Bias is a problem, an error in the design of a study. We either enrolled the wrong people in our study, and we have what is known as a selection bias, or we've measured things incorrectly on people, and we have what is known as a measurement bias. Either way, the result is we measure an association that's the wrong value. It doesn't really reflect the true association between some risk factor and some outcome. And biases can happen in cohort studies like we've been talking about. And I want to talk about three potentials for bias in cohort studies. The first is a measurement bias. Let's suppose you want to look at the relationship between oral contraceptive use among women and their subsequent risk of developing breast cancer. So what you plan to do is a cohort study. You're going to enroll women. Some of them are using oral contraceptives, some of them are not. You're following them forwards in time, and you're seeing who develops breast cancer and who doesn't develop breast cancer. And during that follow-up, you're going to be determining from medical records whether this diagnosis of breast cancer has been made. Now, what I want to talk about now is a potential measurement bias, meaning that we might be measuring people incorrectly in this study. So let's suppose that people suspect there might be a causal link between oral contraceptive use and breast cancer development. Women themselves might be aware of that potential, or their physicians might be aware of that potential. And as a result, those women or their physicians will recommend that those women undergo more frequent testing during a period of their lives. So the women who are exposed to breast cancer see their doctors more often. Their doctors recommend mammograms more often than the women who are not on oral contraceptive use. Now, how could that cause a problem? Well, one issue might be that the breast cancers that occur among the women using oral contraceptives are detected earlier than they normally would have been because of this more frequent testing. And as a result, the period of follow-up, the person time, is shorter among those women who are using oral contraceptives than not using oral contraceptives. Another implication of this is maybe the women who are not using oral contraceptives are not being tested that often. They're developing breast cancer, but we're not knowing about them. That's not being recorded among them because they were never tested. Either way, what you're going to have is a measurement error. We're measuring things differently in one group than in another group. We're measuring outcomes perhaps more correctly earlier when they actually are occurring among the women using breast cancers, and we're missing cases of breast cancer, or delaying their diagnosis in the women who are not being used oral contraceptives. That could lead to a bias. That could lead to an incidence rate ratio or a risk ratio that says there's more disease happening among the women on oral contraceptives when in reality it's just due to the over-surveillance. So how can you resolve that bias? How can you avoid it in the study? Well, the way to do it is to build equal surveillance in the two groups that you're comparing. Do as frequently testing in one group as in another group. And remember, that's one of the nice features of the Framingham-Hart study, the study that we're using in our data sets. The Framingham-Hart study is an example of a cohort study where everyone is being evaluated somewhat equally. Everyone is asked to come back to these testing centers every 2 years, and not only be asked, since the last time we saw you, have you been diagnosed with a certain condition? Those answers might be impacted by the type of bias I'm referring to. But in addition to that, the participants of the Framingham-Hart study are being evaluated and being tested at that time. And the testing mechanism is the same for both people in an exposed group as for people in a non-exposed group. So building equal surveillance is a way to try to minimize this potential of a measurement bias. So that's one potential bias to think about in a cohort study. Let me give you another example of a measurement bias. Let's suppose we're looking at the relationship between a certain medication, say statin use, and quality of life. We have a group of people for one reason or another who are taking statins, another group of people are not taking statins. They're being followed over time and their quality of life is being ascertained at some time in the future. And the way it's being ascertained is an interviewer either calls them on the phone or knocks on their door and asks them a series of questions. Now, unlike the experimental studies of last week, the participants in this cohort study are not blinded to whether they're taking statins or not. If someone knocks on my door tonight and asks me the question, are you currently taking one of these medications, one of these statins, I can answer honestly whether I do or do not. I know that information. I haven't been given a pill and not told whether this pill is a placebo or a statin, as you have in an experimental study. In a cohort study, the ones we're talking about, the exposure is known to the participants. They know whether they're taking statin use or not. So that information might influence how I answer your questions when you ask me about my quality of life. If I believe that statins lead to better quality of life, maybe my answers might be a little bit different, given that knowledge and the fact that I'm taking statins, than they would be given that knowledge if I had not been taking statins. So there's a possibility that knowledge of the exposure on the individual themselves might influence how they answer questions, either directly or indirectly, consciously or unconsciously. But there's another key player involved in this measurement of the outcomes. We're talking about the reporting of the outcome from the participant and the recording of that outcome by the interviewer. So both the reporting and the recording matter when I measure my outcome. So maybe the interviewer has their own opinion about the role of statins and their influence on a person's quality of life. And if that interviewer knows that I'm talking to a person that's taking statin, or knows that they're talking to a person who's not taking a statin, the way they record information, the way they interpret the results might be different, whether they did or did not, whether the participant is or is not taking statins. Well, that knowledge of whether a person is or is not taking statin might be able to be blinded now to the interviewer. But if one of the research questions the interviewer is asking is, are you currently taking a statin? And the participant says yes or no, then now the interviewer knows both the exposure status and the answers that a person's giving to their quality of life questions. So there's a potential now for a bias. Well, is there still a way to try to blind the interviewer in some sense, to minimize the potential for a recording bias? Well, what you could do is blind the interviewer to the hypothesis itself. The interviewer doesn't know that they're doing a study where the investigator, the principal investigator for the study, wants to know whether statin use is influencing a person's quality of life. The interviewer doesn't know that the answer to the statin question is the exposure of interest, and therefore they can't use that knowledge to influence how they record the outcomes on that individual. So there is a potential, at least, to minimize the role of this reporting bias, perhaps by blinding the interviewer to the research question itself, what the exposure is and what the outcome is for this particular study. So that's another type of bias. Now I'd like to talk about a third that has potentially the greatest potential in cohort studies. It's now talking about a selection bias. And it's a selection bias due to losses to follow-up. This goes way back to the beginning of this course when we talked about cumulative incidence and incidence rates. I said to measure a cumulative incidence, you have to have a group of people follow for a fixed period of time where everyone either develops an outcome or lasts for that full period of time and the study ends. And we've been using as an example of data to calculate cumulative incidence, overall mortality in the Framingham Heart Study. But we also talked about other outcomes in the Framingham Heart Study. For example, the development of coronary heart disease, and talked about the problems caused by losses to follow-up or losses due to competing risks, where people were planned to be followed for 5, 10, 20 years, or to the development of coronary heart disease, but people might have been no longer at risk for developing heart disease because they died from, say, a cancer. And we don't know what would happen to that person, had they not died from that cancer, whether they would or would not have gone on to develop coronary heart disease. Or more practically, if a person leaves the study, their losses to follow-up, they move away from your region, You don't know what happened to them after they leave your study. You don't know whether they developed the outcome or didn't develop the outcome. Well, the way we resolved that problem was calculating incidence rates, cases divided by person time. But I made the point at that time that that calculation only is valid if the reason a person is lost has nothing to do with the risk of developing the outcome. We have to assume that the people who are moving out of Framingham are no longer a part of the Framingham Heart Study, no longer coming back for their 2-year examinations, are not the sickest people, they're not the least sick people, they're people whose risk is essentially average among everybody in the study. Otherwise, if we were losing the sickest people, our incidence rate calculation would underestimate the true incidence rate if those people had not been lost. So the problem with losses to follow-up happens if the reason for being lost is related to the exposure. If the sickest people are leaving Framingham or the least sick people are leaving Framingham. So for example, if the smokers in your study start developing symptoms of coronary heart disease and they change their life, and one of the things they do, they move to another region of the country to seek care from a specialist in that country, they are now losses to follow-up. And who are we losing? We're losing people in the exposed group who are at higher risk of developing coronary heart disease. The incidence rate we measure among the remaining people in the study, the remaining smokers, is going to underestimate the incidence rates that all the smokers would have had they not been lost to follow-up. The resulting rate ratio, therefore, would be biased. So typically, we do our best to avoid losses to follow-up. If we lose people, we try to have contact information to still measure outcomes on them. For overall mortality, that's easy. If we know the person's social security number, we can measure on the web whether a person has died and whether a death certificate has been filed in our country. So even though the person might be lost to follow up for other outcomes, they might not be lost for overall mortality. Beyond that, we want to build into our cohort study a mechanism to be able to at least track people if they do become lost to follow-up, to try to measure outcomes. And that's what Framingham has done. They build a network of contact information for each person. So if the individual is lost from their study, they can still talk to their relatives and find out to some extent how that person is, whether they've developed certain outcomes. What we're trying to do is minimize the potential for a selection bias causing an invalid result in a cohort study. Well, that's the role of bias in cohort studies. It's a serious problem. It's a serious problem in any study design. The next time we get together, I'd like to talk about another potential problem in the interpretation of results from cohort studies, namely confounding. So I'll see you next time.